All right, cool. We are going to talk about difference of squares. Hopefully, you've got these notes. Difference of squares is a lot of just memorizing a pattern, recognizing patterns, recognizing numbers, special numbers that will tell you when you can use this pattern. And what's going on is we talked about factoring with GCF the other day, which had to do with distributing. And of course, distributing is if you have some sort of question like this, and you distribute the 5, and you distribute the 5, and you get 25x plus 15. Not off to a good start. 25. But today, with difference of squares, we're basically talking about foiling and working with foiling instead. So we'll do a little review of this since it's probably been a while since you thought about this, and it was probably easy a year ago, but it's been a year. So foiling is when you have a binomial times another binomial, basically a double times a double, and all you need to do is just basically distribute the first to both of them and then distribute the second to both of them as well. So you're going to get 3x squared plus 6x, and then you need to also multiply these and get x, and you need to also multiply this and get 2. And then, again, this is all review, so 90% of the time, these middle two terms are going to combine as well, and you're going to get 7x. And so you'll end up with an answer something like this. So this is foiling. This should be comfortable. Now, obviously, with distributing, you didn't learn how to distribute on Monday, but you learned how to undistribute, how to go backwards and say 25 and 15. They both can be divided by 5, so we can undistribute a 5 and be left over with 5x plus 3. And so our goal today is the same thing. We're going to try to start looking at, can we see something like this and go back up to double times double, okay? Now, that is definitely when the class will start to get a little bit harder. And what we're going to work on today is not exactly doing this process, but more so looking at a very specific kind of like niche use of this kind of strategy. Okay, we're going to look at all of the weird questions today. Instead of looking at like the normal questions, we're going to be looking at the weird stuff. So up at the top, we've got difference of squares. We'll talk about this name in a second. Looking at these examples, this is the question, and this is the triple. Okay, this is the x squared plus x plus no x. And then this is the answer. Okay, now this is definitely, like I said, a weird start. If we imagine that this would be our triple that we were going to try to break down into two doubles, there's only two things here, right? It doesn't look like a triple. Now, what's going on is that basically we have the x squared, and then we have no middle term. I guess I don't want to use x because we already have x's. But we have no middle term, and then we have the number at the end that has no x's at all, okay? And so, sorry I have to scroll down so far, but again, we're going to try to go from this triple back up to these doubles, but we don't have this middle term at all, which is definitely weird. It's definitely unusual, and that's why we're working on it. So what ends up happening? Now, this is an example, and so the answers are provided to you. The answer is x minus 7 and x plus 7, and let's see why this answer works out. We get x times x, which makes x squared. We get x times 7, which makes 7x. Then we get negative 7 times x, which makes negative 7x. And then we get negative 7 times positive 7, which makes negative 49. So what we've got is the x squared, which we need. We've got the 49 that's negative, which we need. And then we've got in the middle here, positive 7 and negative 7. And these are going to cancel out. And so that is how we can take this triple that's really missing its middle term and factor it into two binomials and kind of get it to work out, even though it's such a weird question. Now, this is very, very particular. Okay, you can only use this if you have the perfect set of circumstances. Okay. Now, good thing is we have a nice name here. We have difference of squares. And that is a really good name. Sometimes in math we get weird names for stuff, but difference, which in math means to subtract, and squares, which we know are perfect square numbers, like 1, 4, 9, 16, 25, etc. We need to have the subtraction of squares. The only time that this pattern will work is if we have a perfect square and a perfect square, and we have a minus. And we'll talk about why we need those types of things. So over here, here's another example. In order to do this, you're going to identify this as, do you have two things? Yes. Are you missing that middle term in the middle? Of course we are. We've only got two. And then, is this a perfect square? Yes. Is this a perfect square? Yes. Is this a perfect square? Is this a perfect square? You've got to have every single thing be a perfect square. And then you need to make sure you have a minus. So we have a minus, check. So we are all good. We are allowed to use difference of squares. Now the pattern, if you didn't pick up the pattern before, the pattern is pretty straightforward as well. We're going to basically need, parentheses so that we can have two doubles. We're going to basically, if this is x squared, we're going to kind of take the square root of that, x. And so over here it's 16, 4, 4. A squared, A. And then we're going to need one of them to be a minus, one of them to be a plus. So we've got one of them as a plus, one of them is a minus. Then we get, really good question. Give me 2 seconds, I'll come back to it. We get the 9, which makes 3 and 3. We get the b squared, which makes b and b. And that's it, right? This is the example question, so of course this is the right answer. So Hazel asked a really good question. Does it matter which order the plus and minus come in, right? Over here we've got minus plus. Over here we've got plus minus, right? Does that make a difference? Basically, if you think about this as being a piece and this as being a piece, and these are multiplied together, you're allowed to rearrange things that are multiplied, right? So if you've got 2 times 3 and you want to rearrange this to be 3 times 2, these are still the same thing. So because you're allowed to rearrange things that are multiplied, if you wanted to rearrange this and put it over here, like 4a minus 3b, and have the minus come first, it's still the same thing. So you're absolutely right, Hazel. You can put minus plus if you like. You can put plus minus if you like. It's all good either way. Doesn't really matter. So at the end of the day, all we need to do is identify that we have perfect squares and then just follow the pattern, which is basically do the square roots and you're done. So going down to number 1, let's get into it. Pick up the speed a little bit. Do we have a perfect square? Yes. Do we have a perfect square here? Do we have a minus sign? Okay, well then we have passed everything we need to do. We have the difference of squares. Here's what I recommend. Parentheses first. We need one of them to be a minus, one of them to be a plus. So who cares? We can do minus plus. We could do plus minus, doesn't matter. And then we're just going to do the square root, and we're going to make sure things go in the order that they're already in, right? So first up is x squared. And so what's the square root of that? Obviously, that one's kind of easy, right? X and x. And then after the minus is a 25. Obviously, that comes from a 5. And so we do 5 and 5. And that's it. That's the whole thing. We're done with the question. This is the answer. Now, when it comes to this, if you wanted to double check, all you would have to do is FOIL, right? So you don't have to do this, but I'll do it just because it's our very first question, right? This would make x squared. This would make 5x. This would make minus 5x. And this would make minus 20. Oh, forgot the 2, minus 25. And so, yeah, perfect. These two things have canceled out. X squared minus 25. Nice. We're very happy. So, going to the second question, we get tested a little bit. We get x squared plus 16. Is this a perfect square? Yes. Is this a perfect square? Yes. Do we have a minus sign? No. We do not have a minus sign. So, what does that mean? Right, that means our pattern, we said our pattern had to be squares. Our pattern had to be a minus. We don't have a minus. Now, follow with me for a second, right? We would imagine that it would look something like this, right? It would look something like this. We know it cannot be minus plus, because if it was minus plus, that would make a minus. And so my question for you guys is it plus plus? Let's try that. If we try plus plus, and we check our answers, we get, let me make that a little better. We get x squared, we get plus 4x, we get plus 4x, we get plus 16. So, happy with the x squared, happy with the 16, but then we get this part. And we need this part to get rid of itself. We need this part to cancel out. But we have plus 4, and that makes 8. And that's bad. Okay, we don't have 8x up here, right? So this is not going to work, right? And if you do minus minus, you're just going to get negative 8. Still not going to be what you want, right? So you have to have one of them is minus, one of them is plus if you want them to cancel out. But if they cancel out, you're going to get minus 16. And so basically, this whole question is impossible to do. Okay, we cannot factor this using difference of squares. There's literally no way that you can use real numbers to factor this. It's actually impossible to do. And so the way we have to call this, and this is something you have to know, this is kind of like a vocab word, is that this is called prime. And that's because what we're trying to do is factor these. And if something cannot be factored, then you call it prime, right? If you have a number like 7 that can't be factored, you say 7 is a prime number. And so this, even though this is a complicated, polynomial, this can still be called prime because you can't factor it, okay? So if you want to write a little note here as a reminder, basically we can't factor because a plus. I don't know how else to say it. But we don't have a minus. We're not able to do this, so we can't factor it. Cool. As you see on the whole rest of the page, they're all minuses. So it's a really easy question if you see a plus because you just stop right away and you put minus. All right, number 3, probably a piece of cake. Do we have perfect squares? Yes, yes, yes. Do we have a minus? Yes. All right, we're in business. We're going to need parenthesis, 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 parenthesis. One of them is a minus, one of them is a plus. The one thing you want to make sure is that you keep everything going in the same order. So the very first thing should be the 9, 3, and 3. Right after the 9 should be the x, x, and x. And then we get to the signs. So then it should be the minus and the plus. So now we're going to the right side. We get 49. Should be 7. 7 and 7. Let's move over to number 4. Number 4, this is our first question that is a little tricky, a little funky. What's the problem with number 4? Right, we have X's and Y's, but that's not a nightmare. We can still handle that. The real problem is that we have 18. And 18 is not a perfect square, right? We have, this is not doing it for us. That's good, that's good, that's good, that's good. But the 18, not good. So if we have a minus, or sorry, if we have a plus, we're completely stuck. We can't do anything. But what happens if we have a number that's not a perfect square? Yeah, I kind of agree with you, Hazel. You can try to make it into a perfect square. Now, you can't change this number, but you could maybe reorganize this number a little bit. Try to rearrange things a little bit to make it look better. So what you're going to have to do for number 4, and I'll give you guys a little note here, get rid of our frowny face because we're happy again, is we're going to start this question with GCF. What we learned the other day, right? Are we able to do a undistribute, a GCF of something from both these numbers? A 2. I agree with you. We're going to be left over with a 9x squared minus 2y squared. And so that's good. We have factored it. And now our 18 has turned into a 9. It was not a perfect square, but now it is, right? Have you found a problem, though? Yeah. Yeah, we had an issue, right? We fixed the 18, but now our 4 is broken. Now 2 is no longer a perfect square. And so at the end of the day, this is it. This is all you can do. Basically, there's nothing else that we can do to try to fix this, okay? Not perfect squares. Nothing we can do. What's really important, though, is that we try GCF, okay? You're going to get to a question where you can't do difference of squares, but if you start with GCF, you'll be able to do difference of squares second. And so you always need to try this before you give up. Before you give up, it's time to do that. All right, let's do number 5. We're going to do this one as one of our last ones together. Difference of squares. Is 1 a perfect square? We got a no and a yes. So, Aiden, if 1 is a perfect square, what times itself equals 1? Yeah, I'd agree with you, right? 1 is 1 times 1. So, yeah, this will work. What about 25? X squared? Y squared? Okay. What about the minus? Of course. So, we're good to go. Difference of squares looks perfect. Parentheses, 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 parentheses. One of them's a minus. One of them's a plus. The hardest thing about this question is you have to keep things in order. Okay? And so when you're doing that, you can't just be putting the X's wherever you want and the Y's wherever you want. So first up is 1. It should be 1 and 1. And now we're going to go to the other side of the sign and do a 5. So the 5 should be over on the other side like this. And then we have X's and Y's. The X comes first, the Y's come second. And so we just have to write them like that. Yeah, we're not allowed to move them around, right? Sometimes people like to say, well, you know what? I just want the X's on over here because I don't want the X, Y's together. And unfortunately, you do not have the security clearance to pull that off. Number 6, number 7, those are pretty straightforward. Normally, I would say you guys give this a chance, but since I'm doing the recording, let's just move straight to number 8, and let's finish up the notes here. So number 8 is 32x squared minus 18y, and we've got some problems. What's our problem, Hazel? And 32. Right, 32 is not a perfect square. 36 would be, but 32 is not. So, yeah, we have problems again, okay? Our perfect squares are not perfect squares at all. And so how can we try to fix these and make them perfect squares? Yeah, you're my man for that. Excellent job, Maurice. We're going to start with GCF, okay? GCF is normally something students are very good at, and the only reason they don't like it is because they always forget about it. And they're like, oh, difference of squares doesn't work. And they forget, start with the GCF. So what can we GCF away from both of these? Not a 6, only a 2. Right, this is 8 times 4. It's not 6 times anything, really. So, yeah, I'd agree with you. We're going to take out a 2. We're going to have, what do we have left over here? 16x squared, 9y squared. And so now, are we good to go? Perfect square? Yes, 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 yes. Now, a lot of times this 2 is going to weird people out because it's out here, right? And this 2 is not a perfect square, right? So maybe you're thinking, well, maybe that's screwing us up. Maybe we're not allowed to do difference of squares. Basically, what we're going to do is we're going to kind of zoom in. I know this looks terrible, but we're going to zoom in, and we're only going to focus on this, okay? We're going to make this look better. We're going to ignore the 2. We're not going to forget about the 2, but we're going to ignore it and only focus on this portion. So, zoom back out a bit. As we look at this inside here, everything's a perfect square. Like I said, we're good to go. We've got parentheses. One of them's a minus, one of them's a plus. Square root of 16, 4. Square root of x squared, easy. Square root of 9, we already did that one. It's a 3. Square root of y squared would be y. All right. Now, here's what happens a lot of times. You box this up, and you lose points because you forget about the 2, okay? Don't forget the 2. It happens all the time. I promise you, somebody in class will forget this. Don't forget the 2. So I'm going to say something a little weird here now to finish up the class. For the first 2 weeks, what we're doing is factoring. And when it comes to factoring, you're trying to start with number 8, 32x squared minus 18y. And by the time you get to the bottom, you're trying to have the same exact thing. And I know that's weird because it looks different, but mathematically, this is the same exact thing as this. Okay? They're the same, right? They have the same graph. If you were going to graph these, they have all the same parts. All we've done is rearrange them. We've reorganized them. We've moved stuff, but we haven't lost anything. We haven't gained anything. It's all the same stuff. It's exactly the same. And so when you start and finish any of these factoring questions, everything that you started with needs to still be here. So if you factor out this 2, you can factor it out, but you've still got to hold on to it until you get to the end, okay? If you're missing the 2, I'm going to have to go back a bit. If you forget the 2 here, this piece right here is only enough to get you this piece, right? And then you're not able to go back up to the top unless you keep the 2. So as weird as this is, basically just keep all your parts. Don't forget anything. It happens a lot of times. People just forget stuff. That's difference of squares. The very, very last thing I'll say to you guys is when it comes to difference of squares, 90% of doing this is recognizing when are you allowed to do it, because the pattern is very easy. And so what I would recommend is maybe on the top of your paper or maybe over here on the side or something, make a list of perfect squares, okay? In Algebra 2, you're expected to know everything squared from 1 to 12 at least, okay? And so what I would recommend is maybe you make a little list here of all the numbers that are perfect squares that you're supposed to remember. So for example, 1, 4, 9, 16, 25, 36, 7 squared, what's that? 49, 8, 9, 81, 10, 11, which is the weirdest one, 121, and then 12. Perfect. So I would recommend you make a little list here. Anytime you see one of these numbers, you should have a little red flag go off. You say, ooh, that's a perfect square. I always joke that, you know, if you're sitting at Panera and they pass out the little buzzer for you and it's buzzer number 64, that you should have a little buzzer go off in your head. Oh, that's so cool. I got a perfect square as my number, right? And then, you know, your wife will be like, oh my God, you're such a loser, dude. But that's okay, because guess what? You're going to get every single difference of square question correct. So anyways, that is the notes. Hopefully this turns out to be not too bad. Number 6 and number 7, I'm sure you guys can handle those on your own.